Learning Target 1D, combining like terms and simplifying. By the end of this lesson, you will be able to simplify an algebraic expression by combining like terms. Remember, we are in Unit 1, so this is all about expressions and simplifying stuff down. We have yet to enter into equations, which we will in Unit 2. So we have a couple vocabulary terms for us as we begin. So the first one says that a term is a number, variable, or product of number and one or more variables. So a term is one quantity together. So for example, 2x would be an example of what a term is. Another example of a term that we could have would be -3, let's say y squared. Both of those are examples of terms. Our second vocabulary word is a coefficient. So a coefficient is the numerical factor of a term. So in our prior two examples, in the first example, 2 right there is the coefficient of that term. And in our second example, -3 is our coefficient in our second term example that we have. Our third vocabulary term is a constant. So a constant is a term that has no variable. So an example of a constant would be 10, or we could say maybe -7. Those would both be constant terms. And then our last vocab term is what like terms are. So like terms have exactly the same variable and exponent. So I'm going to list a couple examples for us to see on here. An example of two terms that are like terms would be 5x and 10x are like terms. Another pair of like terms would be -2x squared and 3x squared are like terms. I also think it's important to think about what are not like terms. So some non-examples I'm going to write down here in green, so these are not like terms, would be -7x and 6x squared are not like terms. And the reason these guys are not like terms is because if we look at the variable that's attached to them, although they both have an x, the first one is an x and the second one is an x squared. So those are not identically the same variable. Versus on our examples up above that were like terms, on the 5x and the 10x, those are both dealing with x's and just x to the first power, so those are like terms. And then the -2x squared and the 3x squared are both like terms because they're both dealing with our term being x squareds. Let's look at our first example down below. So in the table below, there are 24 terms, and our goal is to group all the like terms together by coloring the boxes with the same color. Now we're going to need quite a few colors, and if you don't have colored pencils or crayons, that's fine. A highlighter could work maybe if you have some of those, or even just different colored pens. Or if you don't have any different colors at all, you could list them below in a list of like terms. So what I want you to do is try to group them all together on your own first. I'm not going to tell you how many different groups there are. I just want you to go through them, all 24 terms, and think about which ones of these are like terms together and group those all, either by coloring them in each box in with the same color that are like terms, or by listing them as a list that are like terms together. So try that and then we'll check it together. Okay, let's check this together. So I'm going to just go through one at a time. So I'm going to start with the 3x, and I'm going to highlight this in yellow. And I'm going to find out, are there any other like terms with the 3x? So I'm going to go down the first row. The -6n will not be, neither will the next guy. -2 is not. Our -5x squared looks close, but it's an x squared, and I'm just looking for x to the first power, so that won't work. So nothing else in the first row. If I go down the second row, again, I have nothing that is a like term. If I keep going down the third row, I end up getting one other like term, which is -3x, and 3x are like terms. And if I look in the last row, -7x would also be a like term with that guy there. So if you're listing these in rows below, I'm going to list them off to the side, but our first set that are all like terms would be the 3x, the -3x, and the -7x. So there's our first group. Let's go find our second group. I'll do this in pink. I'll just go to the next box over, so -6n. I want to find any other like terms with the negative 6n. I see this 2n down here, and I believe those are the only two. So if I list that, our second group, which are like terms, would be negative 6n and 2n. If we keep highlighting here, let's check our next set. So let's see if I have any like terms with negative 10xy. So nothing else in the first row has both an x and a y, where they're both to the first power. In our second row, this 8xy squared looks close, but the issue is that the y is squared versus being to the first, so that one won't work. But in our third row, I have a 2xy, so that guy can go together. And then in our third row, again, although 10x squared y looks close to it, the issue again is that exponent on the x is not going to match. So for this third group, I only have two of them again, which would be negative 10xy and 2xy are going to be like terms. Okay, let's see what would be a like term with our negative 2. So a negative 2 here, this would be an example of a constant term because there is no variable, there's just the number. So I'm going to look and see if I have any other constants. 4 is a constant. The other constant we have is a negative 1. So again, we can label these are constant terms since there is no variable. I'll label this group 4. I have negative 2, 4, and negative 1 together. Okay, let's find our next group. So negative 5x squared. So now I want all the ones that just have an x squared as the variable. So I also we have a negative 2x squared. That one will work. We have a positive 2x squared and a 7x squared. So this group had quite a few in them. So I'm going to label this group 5. Had negative 5x squared in it. We have negative 2x squared, positive 2x squared, and then 7x squared as well. Okay, I'm going to need another highlighter color. Why don't we use orange this time? So I'm going to look for the y's now. So for the 8y, let's see if there's any other ones. The negative 5y squared is close, but again, I need the exponents to match, so that won't work. I have a negative 1y or a negative y. That will be a like term, and so will 5y. So that will be our sixth group. If I can fit it here, let me scroll down a little bit. So we have 8y, negative y, and 5y. Okay. We haven't done red, I don't think. Hopefully this won't be too dark. I'll do it in a smaller one. So going down to our second row, now we're looking at these y squareds. So I'm going to circle it because it's rather dark, so I want us to still be able to see it, but y squareds. So we also have a 13y squared, and we have a 3y squared down here. So that will be our group 7 then, which will be negative 5y squared and 13y squared, as well as 3y squared. Okay, we have 4 terms left that we have yet to put in a group. Let's see if they'll all be together or if they will be different. So I'm going to actually use a pen instead and just start circling these. So I'll circle the next group with blue pen. So we have 8xy squared. Do I have any other xy squareds? I have one that looks close. 10x squared y looks really close, but those are not identical because the square in one of them is on the y versus the square on the other one is on the x. So those are not like terms, which means our 8th group here is just all by itself. We just have the 8xy squared with nothing else that is a like term with it. Okay, our next group I'll circle in green will be 11m. So I do have one other like term that is negative 23m. So that will be group 9, will be 11m, and negative 23m. And those guys will go together, which means I have one last term left by itself, which is also the only one that's going to be in group 10, which will be 10x squared y. So we ended up having 10 different sets of like terms here, and you can tell in some groups we had a couple that were like terms, and then in other groups we just had one single term that had no other like terms. So combining like terms is an extremely important skill, and we have to make sure that everything is matching up. So the variables have to be the same to be able to have like terms, which means not only the variable the same, but the exponent on that variable is also the same. All right, let's do some examples where we are going to combine these together. So to combine like terms, we can do that anytime we have like terms in an algebraic expression, we can combine them by using operations, addition or subtraction, whatever is in the problem, that is connecting the terms together. So I want us to do a couple examples on our own first. So our first kind of mini example will be 2x plus 5x. So both 2x and 5x are like terms because my variable is the same in each and to the same exponent. So the operation we're going to use is addition because that was given to us in the problem with the plus sign. And when I'm adding like terms together, we are adding the coefficients of those like terms together. So what I'm going to add together is the 2 and the 5. So I'll end up with 7, and I'll end up with 7x of those. So the quantity of the variable does not change. So when I have 2x plus 5x, what I am adding together is the coefficients of our like terms. So the 2 plus the 5 gives me 7, and I have 7x of those. You can think about this as a quantity of something. So I'll use kind of a classic example of, let's say, apples. So if I'm counting apples at a grocery store and I have a bag that has 2 apples in it, and then my friend got a bag that had 5 apples in it, if I were to total the amount of apples, I would have 2 of them plus 5 of them, so I would have 7 total apples. So make sure that when you're adding like terms together, the variable will not change. I just end up adding the coefficients together. Let's look at a second example. What if we have 3x squared minus 9x squared? Again, we do have like terms because I have the same variable. They're both an x squared. In this case, we're dealing with subtraction since I'm subtracting 9x squared in this problem. And just like before, I want to make sure that we are combining our like terms by subtracting our coefficients. So if I have 3 of something minus 9 of that amount, I'll end up with negative 6 of, in this case, x squared. So when I'm subtracting my like terms, I'm subtracting their coefficients. So 3 minus 9 of them will give me negative 6x squared. Let's look at our first example that's typed out. So all of example 2 is saying simplify the following algebraic expressions. So we have quite a few terms going on here. We have 4 plus 3x minus 1 minus 2x. So I have 4 terms here, and we're going to look for ones that are like terms together. So I'm noticing that I have a constant here, which is a 4. Are there any other like terms that would go with the 4? The other like term that I have is that negative 1, so I'll be able to add those together, or actually subtract in this case. Now let's look at the 3x. So I have a positive 3x here, and I also have a negative 2x, and those are both like terms, which is why I'm highlighting them both in green. So in this problem, we have 2 different types of terms. We have our constant terms, the 4 and the negative 1. And then we have these x terms, which is positive 3x minus 2x. So when I go to combine like terms, then I'm going to combine the constants together. So I'm going to kind of regroup these. So I'm going to have 4 minus 1 by grouping the constants next to each other, plus 3x minus 2x. Now, as you're starting off combining like terms, this can be a very helpful step so that you can see the like terms next to each other. But as you start to get more practice and you get better and better with this concept, if you don't feel the need to write this step anymore, then that's fine. It's not necessary to go ahead and write it. It's just there as an added step in case you want it. Now that I have my like terms next to each other, I'm going to go ahead and combine them. So 4 minus 1 will be positive 3, and then 3x minus 2x. Remember, I'm going to subtract my coefficients, so I'll have negative 1x, or just negative x in that case. Now from here, although my answer is not one final number, that's okay. I have simplified this as far as I can go because I have no more like terms that I can combine. So 3 and negative x are not like terms because 3 is a constant and x is not. So I am done, and that is actually going to be my final answer there. Okay, why don't you guys pause the video and try example B on your own first, and then we'll check it together. Okay, let's check 2b. So 2b says 7x squared minus 4x plus 5 plus 6x. So I'm going to go ahead and highlight stuff again just to help me. So I'm going to start with my first term here, which is 7x squared. Now when I look at my three other terms, there's no other term with an x squared, so I don't have any like terms with that, so that's not going to get combined with anybody. So I'll look at my next term here. So my next term is a negative 4x. I do have one other like term that will match with that guy, which will be positive 6x. Let me highlight the plus sign too. And then my last term in here is this plus 5, which again doesn't have any other like terms with it, so there'll be nothing to combine it with. I'm going to go ahead and do all the simplification in one step here. So the 7x squared is going to stay because there's no other like terms to combine it with. The negative 4x and the positive 6x I can combine by adding their coefficients. So negative 4 plus 6 will give me a positive 2, and I'll end up with positive 2x. And then plus 5 is my other term, and there's no like terms to combine with that guy, so he will be left unchanged. From here, I can't simplify any further because none of these are like terms. So although both the 7x squared and a 2x have an x in it, they are not like terms because their exponents are not the same. Okay, why don't you guys try example 2c on your own first, and then we'll check it together. Okay, let's check example 2c. So when I go through this, let's go back to our highlighter. So I'm going to highlight the 5y. There's one term. Now there's no other terms with a y to the first power in it, so I can't combine 5y with anything. That's okay. On this next term, I have a negative 3x. Well, I have no other terms with an x to the first power, so I can't combine anything with that guy. We saw that before. That's okay. I now have a plus 4. Well, I have no other constant term, so there's nothing else to combine that guy with. And our last term here is completely different as well. It's a 2x squared, and I have no other x squared terms, so there's nothing else I can combine that with. So none of these are like terms, which means I cannot simplify this any further. So my final answer is actually the problem they gave me. So my final answer will just be the original problem, since I cannot simplify this any further. And that's okay. Sometimes we don't get down to a single numerical answer. We might have a bunch of terms, but this will be our final answer because I have no like terms, which means there's nothing to simplify. Okay, let's look at example 2D. I'm going to have you guys pause the video again and try it on your own first. Okay, let's check 2D. So we have our first term here is a 3m. Now if I check my next term is a negative 2, well those aren't like terms, but I do have a 6m, so that's a like term, so I'll be able to combine those. Then I have a plus 3. So the negative 2 and the plus 3 are both constant, so those are like terms, so I will be able to combine them together. So let's start with our terms highlighted in yellow, the 3m and the positive 6m. So when I add those together, remember I'm adding the coefficients, so 3 of them plus 6 of them will give me 9m of them. And then negative 2 plus 3 I can combine since they're both constants, and negative 2 plus 3 will give me a positive 1. And from here, I can't simplify it any further because 9m and positive 1 are not like terms. Okay, again, I'm going to have you guys pause the video and try 2e on your own first. Okay, let's check 2e. So we have a 3p, so let's see if we have any other like terms that go with 3p. Do we have any other like terms that go with 3p? We also have the negative 6p, so that one will be able to combine, and that is the only other like term with the 3p. So let's check the next guy. So I have a p squared. Are there any other like terms that will go with a p squared? We do have this last term here, which is a positive 10p squared, so those guys are like terms, and I'll combine them together. Then our negative 5 is a constant term, and so is our positive 3, so I can combine those guys together. Now from here, now that we've identified what all of the like terms are, let's add and subtract them together. So for the 3p and the negative 6p, remember or in this case, we're subtracting our coefficients. So 3 of them minus 6 of them will give me negative 3 of them, so negative 3p. For our p squareds, I have technically, remember, there's our invisible 1 in front, so I have 1p squared plus 10p squared, so I'm going to end up with 11 of them, so 11p squareds. And then for our constant, negative 5 plus 3 will give me negative 2 of them. And since none of those are like terms, I am done simplifying. So if we look back at our prior example, since we've color-coded all of this, we can see that however many different colors we had to use was the amount of terms that I ended up with at the end. So in our first example, we had 2 different colors here. We had the constants and the x terms, and that makes sense because when I got down to my final answer, I have a constant and I have an x term. Same thing with example B. We had 3 different colors that we had to use. Our x squared, our x terms, and then our constant, and we ended up with our x squared, our x terms, and then our constants. Then like we saw in example C, they were all different like terms, which is why I still ended up with 4 different terms. And then in part D, we had 2 different types, the m's and the constants. And then in part E, we had 3 different types, which is why we ended up with our p's, our p squareds, and our constant terms. Okay, here comes our last example in this unit. Why don't you guys do 1 or 2F on your own first, and then we'll check them. Okay, so let's check 2F. So I'm going to start with our 3t. Do I have any other like terms that go with our 3t? We also have this negative t, so I can combine them with that guy. And then no other like terms with them, so those 2 will get combined. Now let's look at our negative 7y. Our negative 7y can get combined with our positive 6y, so those guys are like terms. Our negative 9w cubed, so now we have a w to the 3rd power, can also get combined with our negative 3w to the 3rd. So those guys are like terms. And then this 8d is all left on its lonesome. We just have the positive 8d. Since I had 4 different colors here, I should end up with 4 different terms in my final answer then. So let's check these. If I start with our 3t and our negative t, when I subtract the coefficients, 3 minus, don't forget there is that invisible 1 in front, 3 minus 1 of them will give me 2t. Now for our negative 7y and our positive 6y, negative 7 of them plus 6 of them will give me negative 1, but we don't usually write the 1. If you want to, you can. It's really not necessary, so I just end up with minus y. Our next one will be our w cubed, so negative 9 minus 3 of them will give me negative 12w cubed. And then our plus 8d, because nobody else was a like term with him to combine. And there is our final answer. And that is the end of Unit 1, where we talked all about simplifying different types of expressions, order of operations, and like terms were some key concepts from Unit 1.